going to explore the technique of rotary evaporation. You'll find that rotary evaporation is something you'll encounter many times in your organic chemistry lab experience. This is a rotary evaporator. It consists of many parts. There is a condenser here, and we have water coming in at one end and going out at the other, being forced through the system by this immersible pump, which I have going at the moment. Then we have a receptacle here, this large flask connected to the condenser. This is going to collect any liquid that condenses off the condenser coils and falls down in here. We also have a trap to which we'll connect our sample a little bit later, and this is rotated by a motor which we regulate from the front here. This is a dial which regulates the temperature of a thermostatic bath. The formula that we use is this. We don't want to fill the round bottom flask more than half full. Now this is a 100 milliliter round bottom flask, and you would not want to fill it more than about 50 milliliters full. I'm going to attach this round bottom flask to the trap using one of these blue plastic clips so that this doesn't fall off when there is no vacuum instated on the apparatus. Now there are two things that we have to concern ourselves when we evaporate a liquid. The first is that the rate of evaporation is going to increase with the lowering of the pressure above the liquid. The second thing is that evaporation is always accompanied by cooling of the system. Consequently, we have to have a water bath which will provide energy to keep the system a little bit warm so that the natural cooling doesn't slow down the rate of evaporation. What I'm going to do first now is to instate the vacuum. So we'll turn it on over here, and then I'm going to close the system with this stopcock. And I've just done that. And you will notice the bubbles that are here. This is the diethyl ether evaporating. Now what I'll do then is to start the flask rotating, and it's already evident that you're getting a little bit of the solid fluorinone forming on the inside of the flask. But you can also detect moisture around here, so that means that this is cooling down. So what I need to do is to lower this into my thermostated water bath. Now I've got the temperature set here for about 50 degrees. That's surely hot enough to keep that diethyl ether constantly evaporating. Turn this up a little bit. And now we just simply wait. When the solvent has all evaporated, it's going to leave behind the solid, which is non-volatile. With our ether fluorinone system, when we raise the sample, the solid material is left behind, this yellow fluorinone. So now we're going to reverse the steps that we first employed when we put the sample on here to remove the solvent. We're going to stop it from spinning. We're going to break the vacuum, turn it off, and then we're going to remove the sample. And you can scrape the fluorinone off the sides of the flask, and then you can put this material in a vial if you wish. And there you've recovered your solid fluorinone from the ether fluorinone solution.